All right, so let's take a look at what happens here in this next question. We're reflecting across the given line. So it's not the x or y axis, but it's an actual line. The line is x equals 6. So what I'm going to do is I'm going to kind of sketch that in. So here's my line x equals 6. I don't have to label it to scale or anything, just a general rule. Okay, and I'm going to plot my point. I'm just going to plot my first point to see what happens here. So I'm going to plot -5, -1. So here's -5, -1. And if I reflect it across this x-axis, or I'm sorry, this vertical line here, x equals 6, what I'm going to do is I'm going to use the distance from that line. So this given point is 6 units to here plus another 5 units. So that's a total of 11 units away. And I'm going to use that to see what happens when I reflect it. Well, which coordinate's going to stay the same if my line of reflection is an x equals 6? The y stays the same, right? So I'm going to go ahead and fill all those in. I know my rule. I'm going to apply that rule to start with. And then when I find my new x has to be the same distance from my reference line as the original. So the original was 11 units. If I go 11 units to the right of x equals 6, what's my new x coordinate? 6 plus 11 is 17. Okay. So with D, the same idea. I'm going to go ahead and plot what I have. So 4, 6. So here's 4, 6. I'm going to look to see what distance is this point from my reference line. The x coordinate 4 is how far from 6? 2. So I need to move it another 2 units. So what's 2 more units to the right of 6? 8. So that's my new x coordinate. And my final one, -6, 5. So when I look here, what's the total distance? So here's 6 units to here plus another 6 units to here, 12. So when I reflect that, it's another 12 units away from 6, which gives me 6 plus 12, or 18. Okay, there's my solution. The area, again, because this is an isometric transformation, is not going to change any between the reflection and the original. And so that would be my solution.